Hey Springs, 8th grade math students. Today we're going to do a test prep. And so this is in case you were gone from the lesson or if you just kind of need me to kind of step through things again with you. So take some notes, have paper, pencil ready, with any video, pause, record, rewind, and that type of deal, just to keep your pace. All right. So these questions will be similar to tomorrow's, except tomorrow's questions are going to be multiple choice. And that test will open at Tuesday during your regular math time. Okay? And it's a one-time test. Here we go. So the first question might look something like this, or one of the questions. So Peyton records her baskets made in practice along with the time she's there shooting hoops. Which number would complete the table so that the relationship is a function? So she shot the ball for 2 hours, 4 hours, 3 hours, and an unknown. And the baskets she made in that amount of time was 75 for 2 hours, 157 buckets in 4 hours, 124 in three, so they don't go in chronological order. And then an unknown time period, she made 162 buckets. So what could, for this to truly be a function, which of these would be accurate? 3 hours, 4 hours, or 5 hours? Or is this table incomplete? Well, if you remember, a function is relationship when you have an input that's the same and has the same output. So if I wanted to say that this was 3 hours, well, that won't work because 3 hours old already told us that there's 124 baskets. So it can't be um, letter A. It's not 3 hours. Inputs of the same cannot have different outputs, which were baskets. Same thing with four. She already shot for four. We already know what she had for four. So that number is not going to change. So B wouldn't be a function. C would be a function because there isn't another input of 5 hours. Therefore, 5 could be a correct response. It could be 6. It could be really anything except for 2, 4, and 3 because the input value. Now, if this output value was, let's say, 157, then it could have 4 hours. Or if it was 75, it could be 2 hours. We already have that. That would be a function. So remember, they must have the input. When the inputs are the same, the output must be the same. And therefore, since the output is different, it cannot be one of these inputs. All right, shifting gears. So here's another question. Again, pause, rewind if you need to. The graph shows Doug's rate of money spent to the weight of berries that he buys. Okay, so let's find his unit rate. So for us to calculate unit rate, remember we want to know the value of one something, one unit, 1 minute of reading, 1 pound of coffee, 1 month of weightlifting, whatever one unit is to find unit rate. So we take the graph and we find the ordered pairs that are obvious on the x and y coordinates. So on this one, I can see that this right here is going to have an y of 24 and an x of 5. So that would be a 5 24. Then you could also find another one. I found one at when he's got 10 pounds of berries, he spent $48. So I can take either of those and divide. So I could divide 48 by 10, or I could divide $24 by 5 pounds. And either way, that unit rate is going to be $4.80 per pound. You could plug in any of these other x and y coordinates. So to find unit rate on a graph, you could find the value of y and divide it by x. So divide y by x. Here's another one. So I'm using my kids' names here, but my son James is a physical trainer. He's paid by the gym he works at $200 for being at the gym per week. He also gets 15 extra dollars for every client that he works with individually. Write an equation that shows the relationship between the number of clients he works with individually and his total income. So by being at the gym, he gets 200 bucks, right? And maybe they have him sweep floors, maybe clean equipment, maybe make sure people are being safe. But when he gets to work with an individual client, he gets more money for personal attention. It's $15. So what would be an equation that would work on this? So I might include a text box. Think about this. The y is kind of what the total amount is, right? The total income, and x is the value variable for clients. So I'm going to just take this text box actually and come down here and show you. So for me, I think I would go y is equal, all right? So he gets $200, and that's no matter what. So plus, and then whatever his rate is. Now he gets $15 times the clients. So this would be the relationship. Y is equal to 200 plus 15x. And if we plug in some numbers, let's say that he works with 4 clients. So I'm going to just take out x and put in 4. So y is then going to be equal to that $200 that he gets just for being there. And then 15 times 4 is 60. So in this case, y is equal to 260. This variable y would change as his number of clients change. So something to kind of think about when you see problems like this. So write an equation that shows relationship. So again, that was y is equal to 200 plus 15x. All right? So let's go on to the next slide. Let me erase this. So here is another one where very similar to on the test. So there's 4 gymnasiums. They pay its trainers a salary plus a commission for working with clients. The trainers are paid different rates based on how long they've worked. Which gym pays its trainers the highest commission per client? Okay, so this is interesting here. So we have 4 different gyms. They all pay their trainers different rates for being there. All we're looking at is the commission per client. So these numbers, you don't want to just look at the highest amount. It's the amount of commission. So that would be the X plus. So they all start at different amounts of money that they get for just being there, for working there. Okay? So what we can do is we can look at the change in each hour. So luckily for us, they're all in clients of 2. So we could take the value of X and the value of Y, and we could figure out what the commission is per client. All right. So in this case, we could go and look at 24-hour fitness, and I'm actually going to do this as I write it. Okay. So 24-hour fitness. Let's take 2 values of X and Y. So I'm going to take 200. I'm going to compare 6 to 4. So I'm going to go $222 minus 198. That's the change in Y over 6 minus 4. That gets me $24 for every 2 extra clients. So that is actually a $24 for 2 clients would be a unit rate of $12 per client. Okay, so if I wanted to just kind of write that here so I knew, I'm going to do 12 over 1. Okay, now let's go to LA Fitness. Let's take another change in X over a change in Y. Again, I'm going to compare 6 to 4 since I did 6 to 4 here. So I'm going to start with $270 minus $250 in change in Y. And that gets me $20 over 6 minus 4. And 6 minus 4 is 2. And so they get $20 for extra 2 clients. So that goes down to a $10 per one, or 20 for 2. So I'm just going to type this here. So far, 24 Hour Fitness does the best job. Let's do the same thing for Orange Theory. I'm going to compare the same X and Y. So I'm going to do 6 and 4. Excuse me. So I'm going to start with the Y. So $268 subtract 252 for the change in Y gets me a change in Y of what? That is $16. And 6 minus 4 clients is 2 clients. So $16 for every 2 clients would be an 8/1 or an $8. So that's not the best one by far. That's actually the worst so far. So an $8 commission per client. So not the best. In fact, the worst. Let's go to Gold's Gym, the final one. So again, I'm going to compare the change in Y. That is $290 minus $260 over 6 and 4, 6 minus 4, and the change in X. So the change in Y is $30, and the change in X is 2. So change in Y is $30, and the change in X is 2. And that gets us a $15 to 1, or $30 for every 2 clients. So after doing that math, when we look at this, again, we ask the question, that should be 15/1, is which gym pays its trainers the highest commission per client? And of course, it's Gold's Gym. So Gold's Gym has the highest. I'm erasing this for my next lesson. Hopefully you wrote that down, or maybe you went back and recorded some notes. All right.